So we continue our talk with types of matter. Mixtures are a physical blend between two or more substances. Those substances would be elements or compounds. So a mixture, there's no chemical bonds between the different substances, elements, or compounds. Now they are not chemically combined. They can be separated by physical means, which we'll talk about in a second, and they do not have constant boiling or melting points. Meaning, if we were to boil a mixture, it would boil off, there would be one boiling point, and then after that boiling point was reached, there'd be another boiling point or melting point. Whereas with a pure substance such as water, if we have pure water, it's going to have the same boiling point at 100 degrees Celsius. And it's going to boil at 100 degrees Celsius until all the water is gone. In a mixture, you don't have that. You'll have, if you have a mixture of, say, water and something else, the water might boil off and then the other substance would boil off later. Let's look at some examples of a mixture. This is a mixture, your Coke. So it looks basically the same thing. It's the same throughout. But it's a mixture. This Coke, there's no such substance called Coke. It's a mixture of different substances. We have carbonated water, which is carbon dioxide and water, caramel color, which is also a mixture, aspartame, phosphoric acid, potassium benzoate, etc., etc. Okay, another mixture is, for instance, you can look in your medicine cabinet. This is isopropyl alcohol. It's 70% isopropyl alcohol. So you can even look at the ingredients, or the active ingredient would be the isopropyl alcohol. That isopropyl alcohol is a substance, but it's mixed in evenly with the inactive ingredient, the water. So this is a mixture, as well as a mixture of hydrogen peroxide. Now the hydrogen peroxide that you get at the store is not pure hydrogen peroxide. This, I believe, is about 5% hydrogen peroxide, and the rest is water. It's a mixture. Steel is not a substance, whereas iron is. Iron is something you can find on the periodic table, whereas steel is actually a mixture of two things you can find on the periodic table, two substances, iron and usually carbon. So they might look similar here, but they have completely different properties. One is a mixture, one is a substance. So one way we can separate mixtures is through a process called distillation. And it's on the concept that mixtures have separate boiling points or melting points. Now, if you look at tap water actually has many different things in it. It's not just pure water. It has water and other things, such as minerals and other chemicals. Now, if it's not pure water we can get from a process called distillation. Tap water is not pure water. What we could do, if we want to get pure water from tap water, is distill it. We can physically separate it because tap water will have different boiling points than the other things inside of it. Now we know water has a boiling point of 100 degrees Celsius. And knowing that, we can boil off, if this is at 100 degrees Celsius, we can boil the water. This is how a distillation works. We boil the water. Here we have, we can say tap water. We apply heat, and now at 100 degrees, the water will start to boil. And when you get boiling, we get water vapor. And now, at this point, the water vapor will be cooled by cold water. So cold water will go through here. This isn't showing a tube from the faucet coming here, and this is a condenser where this is a separate tube in here and then an outside tube, and there's cold water here, and that cools the water vapor, the hot water, and it makes it into liquid water again, and we get drops of fresh water, okay, or I should say pure water. Okay, because we are boiling off the pure water at 100 degrees, we're cooling it, and now we get the pure water. What's left behind is all that other stuff. Now, another way or another place that you'll see this is in distilling alcohol. Let's say, for instance, we want to separate alcohol from water. You're out there in the desert, but all you have is some vodka, and you don't want to be drinking vodka. But you do have a distillation apparatus, for instance, and so what you'll do is you'll put the alcohol mixture. So let's say we do have vodka. But vodka is, when you drink it, it's not pure alcohol. You never really drink pure alcohol. You would not last long if you drink pure alcohol. It's a mixture of that alcohol and water. Now, if we wanted just to get the water off, or pure alcohol, for instance, we could boil it off. Now, alcohol, depending on the type, has different boiling points. It's lower, so we have a lower boiling point than water. So the concept is we could boil off the water first. We can boil off the alcohol. So the alcohol will boil at a lower temperature, say 70 degrees Celsius. It will boil off, and then we can condense it, and we'll get the alcohol distillate. And what we will be left with is the water. Okay, so distillation is a great way to separate mixtures, physical mixtures. Now, there's also a way this is a way you can purify water. You can boil off, you can take salt water, and you can boil off the water, and then you get pure water. And in another way they can try this, there's these apparatuses that I can't remember the names of it, but you put dirty water in here. It can even be somewhat polluted. You put it outside, and the sun will beat down upon it, and through evaporation we'll get the pure water will evaporate, and we'll get water droplets. We'll get pure water droplets on top. And what happens with this apparatus is those pure water droplets will then, the water vapor condenses into those droplets, and the water will go off to the side in these collecting areas. And now on the side we have pure water. So we had this dirty water in here, evaporation took place, and then we got a pure water that came off on the side. So now we'll look at the types of mixtures. Types of mixtures, we have homogeneous mixtures and heterogeneous mixtures. Homogeneous, or potato. So I think you can probably tell the difference between a homogeneous mixture and a heterogeneous mixture. So we have this cola here. That is homo, or the same throughout. Hetero would be different throughout. And you can physically, or you can actually see the difference. We have all these M&Ms here. But you can't really see the difference between homogeneous mixtures, but they are not a substance. They are not chemically combined. Okay, so there's no substance that was pure, whether an element or a compound, that is an orange crush. So homogeneous mixtures, such as cola, and heterogeneous mixtures, say like the M&Ms. Homogeneous mixtures look the same throughout, but can be separated by physical means, like distillations, which we talked about. Centrifuge, we'll go more into that later as well, but centrifuge, basically you put test tubes of mixtures in a spinning apparatus, and it spins around, and with the speed that it spins around will cause the mixture to separate. It's kind of like when you're in one of those centrifuges at an amusement park, your stomach somewhat separates from the rest of your body. Filtering, like when you filter coffee, that's a way. Chromatography is another way, and we'll talk about those as well. So examples of homogeneous mixtures: milk, cola, tap water is homogeneous mixture, rubbing alcohol, which we talked about as well, hydrogen peroxide, etc. So basically, if it looks the same throughout, it will be a homogeneous mixture. Heterogeneous mixture is the composition looks different but not uniform throughout, so easily separated by physical means. So with a fruit salad or salads are good examples, gravel chili, things that you can really see. They're much easier to separate because you can see it. You can just pick out those different, like if you have a fruit salad, you can pick out the oranges, the walnuts, the bologna, the M&Ms from your salad. Okay, so this is a chart that we can use to see and identify if things are, what type of mixture they are, what type of substance it is. And this is actually quite a fun game you can play at your parties. I often bring this chart to parties, and it's a big hit. So what you do is, how you play this is you take something like a mixture, or it might not be a mixture, just you take something. So here we have something, and we look at, we start at the top, and we say, okay, well, this is matter, but what is it? We go down here, say, is it uniform throughout? Well, no, it's not. And so that means it's a homogeneous mixture. It's not uniform, it's not the same throughout. So that's homogeneous mixture. Hey, pretty fun. Let's look at this other thing here. This Lipton green tea. Very tasty. Okay, now, going at the top, is it uniform throughout? Yes, it is. Now, so it's homogeneous. Now, can it be separated by physical means? Yes, it can, because we know that it is a mixture. We kind of have to know this really beforehand. It is a mixture. So it can be separated by physical means. It's a homogeneous mixture, so that's a solution. Now, if we took, let's say, tap water, you're going to have to somewhat know what's in it when you play this game. So if we have tap water, we really must understand, and we hopefully we know right by now that it's tap water is not pure water. So if it can be separated by physical means, it's a mixture. It's a solution. So when you're drinking tap water, it's a solution. Now let's say we have distilled water. Distilled water cannot be separated by physical means such as distillation. So it's a pure substance. Now, can it be decomposed into substances by chemical processes? Yes, it can. So that's a compound. We can break up through chemical processes, through chemistry, which we'll talk about later, of course. H2O can be broken up into hydrogen and oxygen through chemical processes. Okay, so here we have a piece of copper. We have to look at go back up to the top. Is it uniform throughout? Yes, it is. So it's a homogeneous substance, or it's a homogeneous piece of matter. Can it be separated by physical means? No. We could do all sorts of things to it. We could melt it, heat it up, bang it, split it, but it's still going to be copper. Those pieces will still be copper, so it's going to be a pure substance. Now, can it be decomposed into substances by chemical process? Well, if it's just copper, that's all it is. It's just copper. It's not chemically combined to anything. It's just one element. So no, it is an element. So this is a lot of fun you can have with mixtures, as you can obviously see.